In this video, we're going to have a look at everybody's least favorite operation, division. It's one of those things that people really struggle to get to grips with from a very early age, and then that fear of dividing sticks with them all the way through school life. But hopefully we're going to be able to get to grips with it today. So I'm going to start off with 25 divided by 3. And there's a couple of different answers up on the screen. I'm not going to go into which one of these answers is the right one, but it'd be quite good for you to have a look at them and see which of these answers, and there may be more than one, you think is the correct answer to 25 divided by 3. Feel free to pause the video here, hit play, and then I'll tell you which one my favorite answer is and why. Okay, so 25 divided by 3, there are two answers that we need to get rid of straight away. Firstly, this 8.3, and also this enormous 8 point, well, lots of 3's. The 8.3 and the 8.3333, the green result, don't have enough of those 3's after the decimal place. The only one that does as a decimal answer is the 8.3 here. And you might be looking at this thinking, well, hang on, it looks very similar to the yellow result, but the difference is this little dot just above the 3. That symbol means recurring, and what it means is you've got your 8, you've got your decimal place, and then the 3, but the dot above the 3 tells you that actually that 3 carries on and on and on infinitely. Now, obviously your hand's going to get tired by writing all of these out, which is why we use the dot to represent that instead. The green and the yellow ones did not have enough of the 3 for them to be accurate. So I'm pretty happy with 8.3 recurring, the blue answer. I'm also reasonably pleased with this one. The correct answer is 8 1/3. All I've done there is I've expressed my answer as a mixed number. And the other one up here, well, it's technically right because 3 will go into 25 8 times and there is 1 left over, so there is a remainder of 1. But at GCSE level we need to be able to deal with that remainder more efficiently, and that's either going to be using the purple answer expressing it as a fraction or using the blue answer expressing it as a recurring decimal. So let's have a look at how we actually do this one. So I've got 483 divided by 3. Now some people like to call this the bus stop method, which is absolutely fine. All I'm going to do is I'm going to set this thing up with 3 on the outside and the 483 on the inside. Now division is just simply an algorithm, and an algorithm is a process that you repeat several steps, stop it, repeat those steps again, stop it, repeat those steps again, and you continue with that process until you arrive at an end point. So that's what we're going to do for division. The first thing we need to do is to take the number on the outside, which is the 3, and we're going to ask ourselves how many times will 3 divide into 4? And the answer to that is 1. There is 1 3 that will fit inside 4. Now the problem is we've got something left over because it will fit in 1 time, but there is a remainder of 1. There's 1 left over. So what I'm going to do with that 1 is I'm going to carry it over to the next column, creating an 18. Then I'm going to repeat the same process. How many times does 3 go into 18? And the answer is 6 times. And this time there's nothing left over, so I've got nothing to roll over to this 3 here. Then I say to myself, how many times does 3 go into the 3? And the answer is 1. And again, nothing left over, so this tells me that I've completed my division algorithm, and the answer to 483 divided by 3 is 161. Here's 3 examples for you to have a practice at. Pause the video here, hit play when you're ready to see the answers. Okay, let's have a quick look at these then. So, again, I'm going to set up my bus stop method. How many times does 2 go into 66514? So how many times does 2 go into 6? Well, it goes in 3 times with nothing left over. How many times does 2 go into this 6? Same again, 3 times and nothing left over. How many times does 2 go into the 5? Well, this time it goes in twice with 1 left over. How many times does 2 go into 11? It goes in 5 times with 1 left over. How many times does 2 go into 14? It goes in 7 times. So the answer to this one, 33,257. The second one, 6485. So if I just set up my bus stop again, 6485. 5 goes into 6 1 time, and it's got 1 left over. 5 goes into 14, well, it will fit inside twice with 4 left over. 5 will fit inside 48 9 times with 3 left over, and 5 will go into 35 7 times exactly. Nothing left over, algorithm complete. The answer is 1,297. The next one, My 3 is going to live on the outside. 19722. How many times will 3 go into 1? Well, it won't, so I'm going to start with a 0 on this one. Carry my 1 over. How many times will 3 go into 19? Well, 3 will go into 19 6 times, because 3 times 6 is 18, and I've got 1 left over there. 3 will go into 17 5 times, with 2 left over. 3 will go into 22 7 times, with 1 left over, and 3 will go into 12 exactly 4 times. So the answer to this one is 6,574. Moving on, we obviously need to look at examples of division where we do end up with a remainder and how we turn that into a decimal answer. So I've set up this question, which is going to give us one of those examples. So let's have a look. The 5 lives on the outside, and then 4, 8, 3 just there. How many times will 5 go into 4? Well, it won't. So I'm going to carry the 4 over. How many times does 5 go into 48? Well, that goes in 9 times, and it leaves me with 3 left over. How many times will 5 go into 33? Well, that goes in 6 times. And what I've got now is I've got this remainder 3. And that's just left over. Now, previously, maybe in primary school, you may have dealt with this and just left it as remainder 3, but we can't do that. Normally, what I would do is I would take the remainder and add it on to the next digit in that number. My problem here is that I don't have any more digits, or do I? So what I'm going to do is I'm just going to put in a very large decimal place and stick in a load of zeros. I'm going to extend my bus stop, and I'm going to duplicate the decimal point on the top line. Now, the problem I previously had was that my remainder of 3 didn't have another digit to go to. Now it does. So I can put the remainder 3 there. How many times does 5 go into 30? Well, 5 goes into 30 6 times with nothing left over. So the division algorithm here is complete. Important thing to remember is when you get to the end of your number, so on mine it was the 3, if you've got a remainder, you need to be able to put it somewhere. So don't forget, you can add a decimal place and as many zeros as you need to add. Now, I just tend to stick a couple of zeros on because at the start I don't know how many of them I'm going to need, and I'd rather have too many than not enough. But it might be the case, like in this one, where you're only going to use one of them. Okay, let's have a look at some practice of these. So hit pause on the video, have a go at these yourself. All of these should produce a remainder which you will need to put into a decimal version. Hit pause, good luck, hit play when you're ready to see the answers. Okay, so in this first one then, I've got 5 going into 8, 6, 5, 3, 4. 5 will go into 8 one time with 3 left over. 5 will go into 36 7 times with 1 left over. 5 will go into 15 3 times with nothing left over. 5 will go into 3, well it won't, so 0, and I'm going to roll the 3 over. 5 will go into 34 6 times. Now I do have a remainder of 4 here, so what I'm going to do is add my decimal places, add in a couple of zeros, and my remainder of 4 I'm just going to put there. 5 will go into 48 times with nothing left over, so my correct answer here is 17,306.8. Having a look at the next one, 4 is into 6677. 4 will go into 6 one time with 2 left over. 4 will go into 26 6 times with 2 left over. 4 will go into 27 6 times again, and this time there's 3 left over. And 4 will go into 37 9 times with a remainder of 1. So I'm going to need somewhere for that remainder 1 to go. So let me just extend this, add in a couple of zeros. Now the remainder of 1 is going to live there. 4's into 10 go twice with 2 left over. So I'm actually got more decimal places on this one. 4 will go into 20 5 times with nothing left over. So the correct answer to this is 1,669.25. Final one then in this section, we're going to be dividing by 8. So 8 lives out the front with 9, 8, 7, 6, 5 on the inside. 8 will go into 9 one time with 1 left over. 8 will go into 18 twice with 2 left over. 8 will go into 27 3 times with 3 left over. 8 will go into 36 4 times with 4 left over. 8 will go into 45 5 times with a remainder of 5. So I'm going to do exactly the same again. Decimal places, extend this decimal point at the top. Now my remainder of 5 is going to live on this digit here, the 0. 8 will go into 50 6 times with 2 left over. 8 will go into 20 2 times, and that's with 4 left over. And 8 will go into 40 exactly 5 times with no remainder. That's the division algorithm complete. Well done if you got all 4 of those correct. Final example I want to look at is where we end up with one of those recurring decimals and how we spot them, how we deal with them. So I'm going to do 3 on the outside and 4, 8, 4 on the inside. 3 will go into 4 one time, we should know this by now, with 1 left over. 3 will go into 18 exactly 6 times, and 3 will go into 4 once, but I've got a remainder of 1 here. So we should now know how to deal with that. Let me put in a couple of zeros because I don't know how many I'm going to need, and extend my line. Now my remainder of 1 will live on this digit. 3 will go into 10 3 times with 1 left over. 3 will go into 10 3 times with 1 left over. 3 will go into 10 3 times with 1 left over. Hopefully what you can see is that this pattern of generating a 10 on the bottom and a 3 on the top is just going to carry on and carry on and carry on. This is the point at which we spot that we've actually ended up with a recurring decimal. So my answer to this one would be 161.3 with the recurring symbol above the 3. What I can't forget to do is to include that recurring symbol. Here are 3 for you to have a go at yourselves. Pause the video here, hit play when you're ready to see what the answers look like. Okay, in the first one then, 3 on the outside, 5, 3, 6, just underneath my bus stop. 3 will go into 5 once with 2 left over. 3 will go into 23 7 times with 2 left over, and 3 will go into 26 8 times with a remainder of 2. So my decimal places are going to be added, and that remainder of 2 can now live there. So 3 will go into 20 6 times with 2 left over. 3 will go into 20 6 times with 2 left over, and hopefully we can see that that's going to create a recurring pattern. So my answer to this one is 178.6 with the recurring symbol up on top of the 6. Next one, I've got 9s into 5, 8, 7, 3. So 9 will go into 5 0 times. I'm going to roll the 5 over. 9 will go into 58 6 times with 4 left over. 9 will go into 47 5 times with 2 left over, and 9 will go into 23 exactly 2 times with 5 left over. So again, I'm going to need to add on my zeros just so I can see what's happening. Now the remainder of 5 can live there. 9 will go into 50 exactly 5 times with 5 left over. 9 will go into 50 5 times with 5 left over, and we should see that that pattern of 50s and 5s is going to carry on. So my answer to this one is 652.5 recurring. Okay, final one then. So we're going to do 587 divided by 6. So 6 will go into 5 0 times, and we carry the 5 over. 6 will go into 58 9 times, and remember 9 times 6 is 54, so we have 4 left over. 6's will go into 47 7 times, because 7 times 6 is 42, so now I've got a remainder of 5. I'm going to add in my decimal places. I'm going to throw a few zeros on and extend my bus stop. Now my remainder of 5 has that 0 to attach itself to. 6 will go into 50 8 times, and 6 times 8 being 48 means I have 2 left over. So this one doesn't immediately look like it's going to start recurring, but let's see what happens. 6 will go into 20 3 times with 2 left over. 6 will go into 20 3 times with 2 left over. And what's going to happen here is, although I've got the 8 to start with, these 3's are going to be the recurring part. So the answer to this one is 97.83. And the recurring symbol lives above this 3 because it's the 3 that carries on. The 8 is just fixed there in place. The 8 is not part of the recurring pattern for this one. Okay, so just to recap with this one, remember not to use any of those remainders. We must be dealing with them as decimal numbers. You carry those remainders over, even if that means that we need to include some hidden zeros after the decimal place. It's not at all something to be scared of. Just remember, this is simple algorithm, step, 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 rinse and repeat until it's complete. And just be careful, watch out and try and spot early recurring digits and patterns. Thanks for watching this video. Hope it was useful. Don't forget to like, share and subscribe.